This is a nice example of a proportional reasoning problem involving two cylinders. So we have two cylinders, one narrow and one wide, each with tick marks to measure the depth of a liquid. When a certain amount of water is poured into the wide cylinder, it reaches the 6th mark. When that same amount of water is poured into the narrow cylinder, it reaches up to the 9th mark. If water is poured into the narrow cylinder so that it reaches the 14th mark, how high would it reach in the wide cylinder? Now, the tick mark it reaches to is going to be proportional between the two cylinders because there's no water, they're both 0. So we can actually use the ratio that we were given. So it went up to the 6th mark in the wide. Well, when it's on the 6th in the wide, it's on the 9th in the narrow. Now here's where we want to be careful. If water is poured into the narrow cylinder, it reaches the 14th mark. Remember how we set this up? Wide on top, narrow on bottom. We always want to match up either vertically, which we didn't, we did wide and narrow, and that's fine, or horizontally. So that 14 has to be on bottom. It's the wide that we're looking for. Let's call it x, and we've set up our proportion. We can now solve. So we can cross multiply the 14 and the 9. So we get 6 times 14 equals 9 times x. 6 times 14 is 84 equals 9x. Divide both sides by 9. We get x equals 84 over 9, which 9 goes into 84 9 times with a remainder of 3, so 9 and 3/9, or 9 and 1/3 tick marks. So it's about 1/3 of the way past the 9th tick mark on the wide cylinder.